So welcome to another video for Cambridge National Award Certificate in Systems Control Engineering R113 Electronic Principles. We've dealt with logic, so most of what we've done so far has been direct current. We've used batteries or a positive rail and a negative rail, and we've pretty much concentrated purely on having a direct current. That's what DC stands for, direct current. But where does that come from? Where do we get our direct current? And this video is going to basically talk about AC, alternating current. And we're going to show how alternating current is generated and how it is transmitted, how it's transformed into DC, direct current that you can actually use. So let's have a look. Where does alternating current come from? Well, we need some sort of power generator. It could be a steam turbine, it could be a solar panel, and in this case I'm going to do a wind turbine. So I've got a wind turbine here, and that's going to rotate, and effectively what we've got in here is some form of generator. And in its simplest terms, a generator and generators and motors are very similar, and they operate on a principle of a rotating coil passing through a magnetic field. Now, if you go on to do A-level, this is something that you'll deal with in a lot more detail. But effectively, the turbine blades or the steam turbines in a power station would rotate, and the coil would spin past the magnets, and effectively what's generated is an alternating current. As the coil passes close to the magnet, you get a very strong current being induced. What's happening is that the electromagnetic field is pushing the electrons in the coil, pushing them around. But when this goes round to the bottom, the electrons are pushed in the opposite direction. So effectively, we call it positive and negative, but actually it is just electrons moving. So the electrons move in the positive, and they turn around, move back the other way, and so on. So we get what's called a sine wave. And you'll have encountered sine in maths to do with triangles, and you might think, well, what has the sine got to do with triangles? Well, it's to do with this. If we just look at a circle for a second, and imagine you've got this point. As you rotate around, well, there's your 0 volts. So when you're at this point or this point, you're generating no electricity. But as you move to the top near the magnet, you're generating a lot of electricity. So that's your peak, if you will. Well, as this point moves, this distance shortens and this distance lengthens. And actually this is to do with trigonometry, and to do with triangles, and to do with sine, cosine and tangent. So we talk about sine waves, because as this moves up to this point, so if we sort of followed this and tracked it, it would move up to the top, and then as it moved down the other side, it would move down here, and then it would go down here, and then it would go up again. So that's how the sine wave for alternating current is generated. And once you've got that, you need to transmit it or send it somewhere. So the next stage is a transformer. You might have seen substations near your house where they have transformers in it, and one of the things that we do is we step the voltage up. So the voltage would come in, so these electrons would move through this coil. This is the symbol for transformer. So electrons would come in through here, and this isn't a piece of iron or something, and the electrons would be moving through here, and they would induce the electrons on this side to do the same thing, to move through the coil, and therefore create an alternating current in this part of the circuit. So there's the transformer. So you would step the voltage up, very high voltage, and then you send that on its way through the national grid. So here's our towers, all connected up. And then eventually this would get near your home, and it would be transformed down again. So it would be stepped down again to a voltage that you would recognise. We use 240 volts. And it would go into your home. Now that's the first stage, if you will, of alternating current. So alternating current, some rotating mechanism takes physical mechanical energy and transforms it into electrical energy by a coil passing through a magnetic field, and this generates a positive, then negative, then positive, then negative. Generates a sine wave. We can use a transformer, which is basically coils of wire wrapped around a piece of iron to induce a current in another coil. We can then send that around the national grid. Eventually it's sent to another transformer and it's stepped down, so we step up and we step down. And I'm going to leave you a little question here. It's to do with the coils, the number of coils on each side. Turns on the primary in relation to turns on the secondary. I'm not going to tell you the answer. I'm going to leave that question for you, so that's something you need to go away and figure out for yourselves. So how do we step it up? How do we step it down? But here you go, it then gets to the house. So, and in your house, you'll have on the wall, come back over here, a plug socket. Like so. And a lot of things in your house will operate quite happily using alternating current. You know, alternating current is quite powerful. There we go. And it can run alternating current, it can run AC motors, it can run washing machines, it can run tumble dryers, it can run dishwashers, it can run the motor in your Hoover. That's all fine. And you know, switch it on and the current alternates. So the electrons move out round your motor and then they alternate back through again. It's almost, you can think of it like as pumping, rather than sort of a constant flow all the way from the power station all the way back again. You can think of it as the energy being pumped backwards and forwards through the motor. But the question now is, how do we get this alternating current into a direct current that we could use in, say for example, a computer or a laptop? Right, to just have a little look at what happens if you ran an alternating current through a diode. So if we put this alternating current through a diode, like so, so there's a symbol here for alternating current source. So So we've got an alternating current, so we'd have a sine wave going in and out. And what would happen as you went through the diode? Remember, a diode's like a one-way, so you would get voltage that way. So if we draw a little graph of that, you'd see this peak, positive, but then you'd see zero, and the electrons are trying to go that way, but they can't. So actually you'd have a gap. You wouldn't have anything, and then you would have another, and so on. Now that's no good, because obviously you've got this period where there's nothing happening, it's off. So we can't, although these are direct currents, they would be peaks. So that's not helped us at all. But there is an arrangement where, and it's worth, again, these are worth learning because they do come up in examinations, where we can use two diodes. This is what we call half wave, because you've got half the wave, and we call it rectification. So this is a half wave rectifier. So what I can do is, remember your transformers. So there's my power coming in from my alternating current, so do that. Like I have two diodes, like so. And then I can have a circuit. And I'll put a resistor here. I'm just going to label this as being the load. This could be anything. This can be your computer, this can be a motor, it can be whatever it is that you need a direct current for. Okay, so now what's happening is, if you imagine the currents coming in, so I'll do this in two different colours. So I'll start off with, let's say we're going that way. Then the induced current would be in that direction. So it can go, can't go through, can't go there, it's going that way, so it's going to go through there, and it's going to go round back into the circuit, because it can't go that way. So that's dealt with one half of the wave. So if we look at that, like so, there's one half like that, and then the other half goes there like that. So that's going that way. Well, now we can go through there. We can't go around that way because there's the stop sign on there, so we can go through there, around there, and back to there. So here on the load we had positive, but when it was negative here, it was going through the diodes in such a way as we had another. So you'd end up with a direct current. Okay, a bit of a wobbly direct current, but actually we can deal with that. So this is a full wave rectifier. Using two diodes. And this actually came up, or this sort of arrangement did come up in an exam question. So again, it is worth working on this and committing it to memory and learning it. Now another option would be a full wave rectification using 4 diodes, and again this has come up in an examination, so it is worth learning. So we have our transformer, like so. I'm going to draw these 4 points like so, and then as I talk while we're around the circuit, I'll explain to you how it works. So get into the habit, if you draw your coils like this and then draw this diamond shape, and then around there you connect your load. So this is going to be your computer or some such, and you're going to add one of the component across your load, across whatever component it is. You're going to add a capacitor. And I'll explain how the capacitor works as part of the circuit. So let's draw the graph. Okay, so let's put electrons in there, and let's do the same there. So what we've got here is the electrons can go along here and they come to this first junction. There's a diode here that allows them to flow. So they can flow up here, through the load, around, and there's another diode in parallel there, allowing that circuit to complete. So it goes through there, around there, up there, and back over the top. That's the first pair. And then if we switch that round, so it's going up, it comes over here. It can't go that way. So we have another diode here. It can go through the load, round, back up, and then it goes through a diode here. Sometimes the Americans call this a Wheatstone bridge, but it's basically a full wave rectification using 4 diodes. So if we looked at what we'd have, we'd get our positive, and we get our negative, and then what do we get? So we've got our direct current. It's still a bit bumpy, and that is where the capacitor comes into play. So here's your capacitor. Now what happens with the capacitor is, if we looked at before, capacitors charge and they discharge. So what we can do is, if you imagine that while that's going on here, as this is charging up, as the load is running, as we've got current running through here, we've also got a charge gathering on the capacitor. And what happens now is when this voltage drops here, we've got this gap, there's nothing going on to the capacitor, there's nothing forcing electrons on here. So now they can discharge. So what can happen is, the capacitor discharges, draw a little triangle line, so it charges up again and it discharges, and it fills that gap. So we get this much smoother direct current wave. Now this can be processed further so that we can get a nice smooth wave. Basically, this is how your AC, your alternating current here, has been processed through the 4 diode full bridge rectification with a capacitor to create a smooth, or reasonably smooth, direct current output. And it's that direct current that will power you, 12 volts perhaps, that will power your laptop, or the 5 volts that you would use to charge your mobile. That's how the plug in the wall powers. So when you plug your computer in, you've got this black box, if you will. Well, that's what's going on inside of that black box to give you your 12 volts. I hope that's been useful. Again, this is the sort of thing that you want to sort of commit to memory. Make sure that you understand how the sine wave is being generated, how it's transmitted, excuse Percy, somebody's obviously arrived at the back door, how it's transformed, how it can be stepped up and stepped down, again a little bit of research for you to go away, how it then can be rectified. A single diode gives you a half wave, 2 diodes would give you a full wave, and if you go for the full 4 diode full wave rectification with a capacitor to smooth the output, you've got direct current for things like your 12 volt laptop or 5 volts for your charging your mobile phone. And I hope you do well on the exam.